Welcome to ZoomInData, your go-to channel for in-depth Azure Cloud, Serverless, and modern development interview preparation. In this video, we dive deep into the top 25 Azure Functions consumption plan scaling interview questions for 2026. Perfect for developers, architects, DevOps engineers, and anyone preparing for AZ-204 certification or optimizing cost-effective, truly serverless workloads. We cover the automatic scaling engine, cold start realities, trigger factors, concurrency limits, scale controller behavior, host, JSON tuning, memory handling, sudden spikes, execution timeouts, monitoring, cost implications during scaling, comparison to premium, state management challenges, testing locally, and best practices for real-world consumption plan deployments, all explained in clear, detailed, interview-ready technical language to help you confidently ace your next interview. 1. How does scaling work in consumption plan? In the consumption plan, scaling is completely automatic and serverless. Azure's Scale Controller continuously monitors event backlog, trigger rate, and instance health to decide when to add or remove instances. The system scales from 0 instances, when idle, up to thousands during peak load, with new instances created on demand and deallocated when no longer needed. There is no concept of reserved or minimum instances. Scaling decisions happen in near real-time based on incoming events. The controller aims to keep CPU utilization balanced and prevent backlog growth. Scale-in is aggressive to minimize cost. Idle instances are removed quickly, while scale-out is fast but can be delayed by cold start provisioning time. 2. Explain cold starts in consumption plan. A cold start occurs when Azure must create a brand new instance to handle an incoming event because no warm instances are available, after idle period or during sudden spikes. The cold start latency includes downloading the function app package, initializing the language runtime, loading extensions, bundles, and starting the worker process. Typically 2 to 10 seconds for .NET, JavaScript, longer for Python or heavy dependencies. Cold starts are most noticeable on the first invocation after idle time or when scaling from 0. They directly impact end-user latency for sporadic or bursty workloads. Consumption plan is the most prone to cold starts among all plans because there are no pre-warmed or always-ready instances to mitigate the delay. 3. What factors trigger scaling in consumption? The primary scaling trigger is the growth of unprocessed event backlog, when the number of pending events, HTTP requests, queue messages, event grid events, etc., exceeds what current instances can handle quickly. High CPU, memory utilization on existing instances also signals the scale controller to add capacity. Sudden spikes in event rate, for example thousands of simultaneous HTTP requests or queue messages, cause rapid scale-out decisions. The scale controller uses machine learning heuristics and real-time metrics to predict future load and proactively add instances before backlog becomes critical. 4. How do you mitigate cold starts in consumption? Use a keep alive pattern. Schedule a lightweight timer-triggered function every 1 to 5 minutes to ping the app and prevent full idle timeout. Works but adds small ongoing cost. Optimize function startup. Minimize dependencies. Use extension bundles. Reduce package size with run from package, and avoid heavy initialization code. Design for idempotency and eventual consistency so occasional cold start delays do not break business logic. For critical low latency paths, Consider migrating to Premium plan where pre-warmed instances eliminate cold starts completely. 5. What is the maximum concurrency per instance? The default maximum concurrency per instance in consumption plan is 200 concurrent executions for most triggers, configurable via host, JSON. Concurrency is controlled by functions_worker_process_count, default 1, and max concurrent calls per worker, default varies by trigger. HTTP triggers default to 200 concurrent requests per instance. Other triggers, queue, blob, etc., have lower defaults to prevent overload. Increasing concurrency improves throughput but can increase memory pressure and risk of throttling if instance resources are exhausted. 6. Explain instance limits in consumption plan. Consumption plan has no hard maximum instance limit defined by Microsoft. It can scale to thousands of instances during extreme load. Practical limit is imposed by the scale controller's throttling behavior and regional capacity availability, rarely hit in normal use. Each instance has memory limits, typically 1.5 GB effective, and CPU allocation that constrain per instance concurrency. You can indirectly limit maximum scale out with website_max_dynamic_application_scale_out app setting, rarely used in practice. 7. How does consumption handle sudden traffic spikes? Consumption plan reacts very quickly to sudden spikes by adding new instances within seconds to minutes when backlog grows. The scale controller uses predictive heuristics based on historical patterns and current event rate to preemptively add capacity. Initial requests during a spike may experience cold start latency until enough instances are provisioned. Premium plan handles spikes with lower latency due to pre-warmed instances. Consumption is more cost-effective but trades off initial response time. 8. What is the execution timeout in consumption? The execution timeout in consumption plan is hard limited to 10 minutes, configurable down to 5 minutes default via function timeout in host, JSON. Any function exceeding the timeout is forcefully terminated, even if still executing. Timer triggers are further restricted to 60 minutes maximum in consumption regardless of function timeout setting. For workloads exceeding 10 minutes, migrate to premium or dedicated plans where timeouts are unbounded. 9. How do you monitor scaling events in consumption? Use the Capacity Metrics app, built-in dashboard, to view instance count over time, scale out, in events, and overload time point analysis. Azure Monitor Metrics provide instance count, scale out triggered, scale in triggered, and throttling events. Application Insights tracks function execution duration and cold start frequency during scale events. Set alerts on high instance count, frequent scaling, or throttling to detect scaling issues early. 10. Explain the scale controller in consumption plan. The scale controller is Azure's internal service that continuously monitors trigger event backlog, instance health, CPU, memory utilization, and historical patterns to make scaling decisions. It adds instances when backlog grows or utilization is high, and removes them when load decreases to minimize cost. Uses machine learning-based prediction to proactively scale before backlog becomes critical. Decisions happen every few seconds. Aggressive scaling keeps costs low but can cause repeated cold starts during intermittent traffic. 11. What is the role of host? JSON in scaling. Host JSON controls per function and per trigger concurrency limits, max concurrent calls, prefetch count, that influence how much work one instance can handle before scaling out. Website_max_dynamic_application_scale_out sets a hard maximum instance count, rarely used. Other settings, singleton mode, health monitoring, indirectly affect scaling behavior and instance stability. Tune concurrency settings carefully. Too low causes unnecessary scale out. Too high causes per instance overload and throttling. 12. How does consumption plan handle memory usage? Each consumption instance has approximately 1.5 GB effective memory available, shared across all functions in the app. Memory usage is tracked per invocation. Exceeding memory causes throttling or instance recycling. Multiple concurrent executions share the same instance memory pool, so high concurrency can lead to out-of-memory errors. Monitor memory metrics in Capacity Metrics app and Application Insights. Reduce dependencies or batch size if memory pressure is high. 13. Explain per function concurrency settings. Per function concurrency is controlled via host. JSON under extensions right pointing arrow bindings right pointing arrow less than trigger type greater than right pointing arrow max concurrent calls. Default is 200 for HTTP triggers, 16 for most others, queue, blob, etc. Can be increased or decreased per trigger type. Higher concurrency improves throughput on a single instance but increases risk of memory, CPU overload. Use carefully. Combine with instance-level concurrency, functions_worker_process_count, for fine-grained tuning. 14. How do you configure max burst in consumption? Consumption plan does not have a direct, max burst, setting. Maximum scale-out is practically unlimited, thousands of instances. Indirectly limit maximum scale with website_max_dynamic_application_scale_out app setting, rarely used. Burst behavior is controlled by the scale controller's heuristics and event backlog growth rate. For controlled bursting, migrate to Premium plan where minimum instances plus autoscale rules give more predictable burst behavior. 15. What is the default scale-out limit? There is no hard default scale-out limit in consumption plan. Azure allows scaling to thousands of instances during extreme load. Practical limits come from regional capacity availability and scale controller throttling to prevent abuse. Website_max_dynamic_application_scale_out can be set to artificially cap maximum instances, for cost control. Most workloads never approach any limit. Monitor via Capacity Metrics app if high scale is expected. 16. How does consumption plan manage costs during scaling? Consumption charges only for actual execution time, GB seconds, and execution count. Idle instances are immediately deallocated with zero cost. During rapid scale-out, new instances are provisioned quickly but cost only starts when they begin executing functions. Scale-in happens aggressively to minimize idle time and cost. No reserved capacity charges exist. Sudden spikes can cause brief higher cost due to many short-lived instances, but overall cost remains proportional to work performed. 17. Explain the difference in scaling versus premium plan. Consumption scales from 0 with potential cold starts and 10-minute timeout. Premium scales from a configurable minimum with pre-warmed instances and no timeout. Consumption has aggressive scale in zero cost when idle. Premium maintains minimum instances continuously, fixed cost. Consumption reacts to backlog after it grows. Premium pre-warmed instances respond instantly and scale faster. Consumption is cheapest for sporadic traffic. Premium is better for latency-sensitive or predictable baseline workloads. 18. How do you handle state in scaling scenarios? Consumption plan instances are stateless by design. Never store state in memory or local disk, ephemeral. Use external durable storage, Azure Storage, Cosmos DB, Redis, or durable functions entities for shared state. Implement idempotency so duplicate processing, possible during scale events, does not cause errors. Avoid in-memory caching. Use distributed cache, Azure Cache for Redis, when needed. 19. What is the impact of long-running functions on scaling? Long-running functions, close to 10-minute limit, tie up instances longer, reducing available capacity for new events and delaying scale-out. Can cause backlog growth and throttling if new events arrive while instances are occupied. Scale controller may add more instances, but long executions still increase cost and latency for queued events. Best practice: break long functions into smaller pieces or migrate to premium, dedicated for unbounded duration. 20. How do you test scaling behavior locally? Local development, func start, does not simulate true scaling, single instance only. Use Azure Load Testing or JMeter to generate high concurrent load against a deployed consumption function app. Monitor instance count and cold start frequency in Capacity Metrics app during load test. Test idempotency and state handling under simulated scale-out, scale-in conditions. 21. Explain consumption plan for sporadic workloads. Consumption is ideal for sporadic workloads, once per hour, daily batch, occasional spikes, because it scales to zero when idle with zero cost. No baseline charges make it extremely cost-effective for unpredictable or low-frequency traffic. Cold starts are acceptable for non-latency critical sporadic tasks, background jobs, scheduled reports. Monitor cold start impact. If latency becomes an issue, consider premium for always-ready instances. 22. How does consumption handle high-throughput triggers? High-throughput triggers, event hubs, event grid, HTTP bursts, cause rapid scale-out as backlog grows. Multiple instances process events in parallel. Scale controller adds capacity aggressively. Limited by 10-minute timeout and per instance concurrency, long-running high-throughput tasks can cause backlog. For sustained high throughput, premium or dedicated plans are usually better due to pre-warmed instances and no timeout. 23. What is the role of website_max_dynamic_application_scale_out? Website_max_dynamic_application_scale_out is an app setting that artificially caps the maximum number of instances the consumption plan can scale out to. Used to control cost or prevent runaway scaling in extreme scenarios, default is unlimited. Rarely needed. Most workloads never approach any practical limit. Set only after careful analysis. Can cause throttling if set too low during spikes. 24. How do you optimize for faster scale-up? Reduce function startup time. Use extension bundles. Minimize dependencies. Run from package deployment. Keep functions lightweight. Offload heavy work to activity functions or external services. Use premium plan for pre-warmed instances if scale-up latency is critical. Monitor scale events in Capacity Metrics app and adjust trigger concurrency settings to balance per instance load. 25. Best practices for consumption plan scaling. Design functions to be small, fast starting, and idempotent so cold starts and scale events do not break logic. Monitor instance count, cold starts, backlog, and throttling regularly using Capacity Metrics app. Use website_dynamic_application_scale_out only when necessary for cost control. Avoid over-constraining scale out. For latency-sensitive or high concurrency workloads, proactively migrate to premium when cold starts or timeouts become issues. Thank you for watching. If this video helps you prepare for your Azure Functions interview, please give it a thumbs up and share it with your network. Don't forget to subscribe to ZoomInData and hit the bell icon for more in-depth cloud computing, serverless, and Azure interview prep videos every week. Drop your questions or topic requests in the comments. Let's zoom in on your success together.